Hello my friends, in this lesson we'll learn one of the most important solid principles in my opinion. Today we are going to talk about dependency inversion principle. As usual, we are going to review origins of the principle. I will explain you why we need to follow it, and on real code examples we will see how to apply the principle. To start with, let's learn first what this principle is about. This principle consists of two major statements. The first one: high-level modules should not depend on low-level modules. Both should depend on abstractions. And the second one: abstractions should not depend on details. Details should depend on abstractions. Probably it's not obvious where inversion happens. Let me explain. It will be hard to explain with words. So, let's look at the code examples and I will show you how dependency inversion happens. Imagine that we are implementing weather aggregator, and our aggregator will use temperature values from different sites and will tell our users average temperature. Right now we have two external weather APIs. The first one is AccuWeather and the second one is BBC Weather. The specific of these two types is return value. AccuWeather returns temperature in Celsius, but BBC Weather returns temperature in Fahrenheit. And to return average temperature in Celsius, we need to convert Fahrenheit to Celsius in our getTemperature method, in our weather aggregator. Everything looks good. What do you think? Now, let's imagine that I want to integrate new weather API into my program. For example, I want to implement World Weather API. And World Weather API returns temperature in kelvins. And what should I do? I have to implement another method here that will convert kelvins to Celsius, and after that I just get temperature method and retest this unit one more time thoroughly. And here we can see that our weather aggregator class depends on the different weather APIs, because each change in the API should lead to changes in my weather aggregator. Imagine that return type become different, or simply method name is changed. All changes in lower modules will impact our high-level module where we have weather aggregator. This is dependency which we have to invert. So how I can make my code easy to maintain, easy to support and to scale? We need to apply dependency inversion principle. Let's recall the first rule. High-level modules should not depend on low-level modules. Both should depend on abstractions. That means I have to create some abstraction and all other classes, Weather Aggregator, AccuWeather API, BBC Weather API, will depend on this abstraction. Let me create interface weather source. This interface declares contract for one single method, getTemperature Celsius. That's it. Why only this method? Why I wouldn't create methods that allows to get temperature in Fahrenheit and Kelvin? Because this is not what is needed for my program. And our weather aggregator now also depends on the abstraction. Here I write code which relies on the interface of weather aggregator. I can create weather aggregator with array of objects with type weather source. In my getTemperature method, I can rely on the weather source interface and assume that each object will be able to return temperature in Celsius. This is method reference here and stream API. Don't worry, I will explain this in separate lessons. What you can understand is that I can easily get average value from multiple weather APIs. And in case I ever need to add new weather API to my program, I can add it to this array and make sure it implemented weather source interface. And you see that we are also in line with open-closed principle. I don't need to modify this class anymore, because my level of abstractions allows me to do so. Now you can see that our high-level module depends on the abstraction. And now it's time to recall the second rule of dependency inversion principle. Abstractions should not depend on details. Details should depend on abstractions. That means I don't care whether API which I'm going to integrate with will return temperature in Celsius or Fahrenheit. I need temperature in Celsius, period. And my abstraction doesn't depend on the details of implementation. My classes which will implement this interface will depend on it, thus depend on the abstraction. For example, BBC Weather API that returns temperature in Fahrenheit. The method which converts Fahrenheit to Celsius is located here now. Now you see the full picture and noticed that both high-level class and low-level classes depend on the abstraction weather source, and we inverted dependency from weather aggregator to concrete API classes. Now concrete API classes depend on the abstraction. Hope with this example things become clearer. Let's recap what we have learned today. Today we learned what is dependency inversion principle. We learned the rules of the principle. On a real code example you saw how we can invert dependency. We discussed how this principle can help us make our code easier to support and to scale. That's all what I have in my plans to discuss with you. Thanks a lot for your attention. See you in the next lesson.